We will speak today about physiology. If anatomy describes things, can you see the screen, my dear? One moment, please. Can you see the screen? And okay, that's all. That's all I want to know. Okay, let's begin. Continue. Anatomy is description. You describe where which organ exists, which bone, how it connected to another bone. Great, my dear. Look on my picture. Here's car given to you. Yeah, for sure. You can describe that this is blue color or purple as you want car with some tires. I do not know how it is in English. Some lights, some mirrors, and so on and so on, and some other kind of details. Great. You can describe it. But can you fix this car? For sure not. You can take some tools on its place, but how it works, what you need for good working of this car, you have no idea. So if anatomy is description, physiology is understanding how this organ works. When we speak about the joint, I know that joint exists from some bones. I know that ligaments exist here, but why it moves? Muscles, only muscles. And if I will cut out my hand from my head and body, will it contract? No, so it's not only muscles. Here must be another regulation. Yes, am I right? Of course. So to understand which regulation, how works, you have to study physiology. It's not only about that contraction exists, but how strong this contraction is. I can take contraction fully till my head or stop it somewhere by my mind. It's different regulation and different form for sure. We will speak about this kind of, but in the beginning, the first portion is slight historical. So, you are intelligent people, you are student of medical school, and please don't ask me why you need this or that history portion. If you know history of medicine, you can be sure what's new and how it developed and or how it changed and how we change our mind. You have to know it. And for sure, intelligent person can speak about past, future, and today's situation. So let's begin. What we say, physiology is the study of normal function within living creatures. Every kind of living creatures, yeah? Not only human beings, but amoeba as well. It's only one cell, but it's a creature, and we can speak about physiology of this one. It is a subsection of biology covering a range of topics that include organs, anatomy cells, biological compounds, and how they all interact between each other, yeah, to make life possible. So, who first begin physiology? In the very first centuries, around 420 BC, father of medicine is named Hippocrates. I think this name is known by everyone because all of you after graduating will give Hippocrates oath. You remember this one? So he is so intelligent that want to know how body works. But in those period, can you imagine it's more than 2,000 years ago, yeah? Slightly about 2,000 years ago, okay. Here is no so developed tools and knowledge like today we have. So he think by his own, and what he said. Hippocrates coined the theory of four humors. Four humors, my dear, stating that the body contains four distinct bodily fluids. He thinks that in our body float some kind of liquid. And if liquid is white, we have one mood. If liquid changed the color and became yellow, black, or red, it's changed some processes in our body. So he thinks that we have all this four fluid inside us and it exchange each other. Let's see. It's black bile, phlegm, blood, and yellow bile. And for sure, it's very, very close to nowadays understanding. What is yellow? Yellow is gallbladders, yes, specific chemical fluid. It has very strong yellow color, and if it is a lot in the digestive tract, it makes some diseases which of course will somehow change our mood. We will become more depressed, maybe on bad mood because we have some problem in digestion. Black bile. When black bile exists, my dear, never see 2 or 3 persons who cut their finger. When you cut finger, have not the same color of the blood. Sometimes it's red, yes, light red, but sometimes it's very dark kind of. So Hippocrates thinks that this very black kind of is black bile, which is floating in our body. And for sure, when it's decreased leukocytes, increased erythrocytes, which gave you this dark color. When it is full of CO2, which makes this color more, how it is, dark red, yes? So it connected with your mood and some diseases. It can be infection, which change the blood formula. It can be other kind of diseases like decreasing some cancer of the blood cells maybe. So of course, this kind of exists and you have to think that he is very close to understanding in those period, 420 BC. Phlegm. What is phlegm, my dear? Phlegm is a white color, yeah? White color, phlegm. I perfectly know that when you look on the person, the first what you see is color of the face, yes? Sometimes it's pale. When it's pale, what happens? We have some problem inside. Our blood can be more pale as well. Yeah? Why it happens? Decreasing of the red blood cells, of course. This point you know for sure from the school as well. So, or low blood pressure. So this kind of can be described in many diseases, pale color. But Hippocrates thinks that it comes from the phlegm fluid. Understand? Nothing new to us, only how he think about it and how clever he was for his period of life. Any disturbance in their ratios, as the theory goes, causes ill health. Another one which you have to remember is Galenus, Gladius, Galenus. It's 130 to 100 AD. So the first, second century, yes? Also known as Galen. So it's shortened from Galenus, Galen. Modified Hippocrates theory and was the first to use experimentation. to derive information about the system of the body. He is widely referred to as the founder of experimental physiology. So why this experiment is so useful to us, and why we mention this person in the history of physiology? Can you imagine the period when cutting of body was against the law? If someone will cut the body, dead body, or how it's cut out or something, yes, he will be taken to the prison and punished as well, maybe killed. So what to do, how to understand what happened inside and how it works? He do some experiments, compare, and try to understand what's happened. He take information. If you are thirsty more than 10 days, you will die. If you have water every day, you are alive. Is it experiment? Of course. Through this, he described what happened with the person in this experiment. Notice it and make some notes for it. And when he finds the same in other, he understands, I remember, I noted. So if he is seeing his skin is dry, lips are dry and fractured, so he was thirsty. Sure, we have to give him water. So this is experiment. It's a simple example for sure, like a joke for you, but you can understand how deep it is, because in the 20th century, worldwide is spreaded experiments theory of digestive tract done by physiologist Pavlov. You remember, yes, these dogs staying with cutting here and some bile is coming out when bulb is light out. They think that food is given to them and some bile is coming from the cutting throat. So it's physiology, my dear. It's experimental physiology. So who is founder? Founder was Galenus, or Claudius Galenus, or Galen, as you want. Okay, let's see the next name. It's Fernel, Jean Fernel, French physician who first introduced the term physiology. So word physiology is given to this subject only in 1497 or 1497. Can you imagine? In those period, okay, not 97, maybe 98, does not matter, but in those period, French physician gives a name to the subject, named it physiology. What it means? It means study of nature or study of origin. Understand, yeah? Okay. Let's go further. We know this one, and here's another kind of picture, the same idea. Everyone can describe what it is, but not everyone can take some music from this too. Am I right? Of course I am. So I cannot. I can only describe that this is glitter, okay? But how it works, where I have to press, what to do to have some extra sound from this tool, like I have no idea. Okay, so it will be physiology to know how to work with it. Now, my dear, from which part is this picture? Let's begin from this one. From which part consists physiology? What we have to think about, what about we will speak in our physiology classes. We will begin from the very elementary, very small particles named atoms. Why, my dear? Because biochemistry, it's how it changed When some chemicals changed, it changed then everything after. Liquid molecular, it consists from atom. If I cut out one atom, it will be another kind of molecular. Another kind of molecular will have another kind of structure, another kind of function as well. One additional oxygen atom makes from oxygen ozone, yes, it's different gases. The same is in the physiology. Okay, atom, then we will describe molecular, then cells, then tissues. From tissues consist organs. So if you know how work atom, molecular, how work the cell of the body, how work group of cells that makes the tissue, how work group of tissues which are in organ, you can understand what can happen, what kind of disease exists, on which structure we have problem. Maybe this molecular exchanging is under the problem, some chemical, how it is, chemical equilibrium is wrong, yes, in our body. So everything will be wrong then. Or maybe you have injury of tissues, mechanical changing, yes, of course. So, or in organ you have some pressure, maybe blood pressure, cancer, massive pressure on the organ, which as well will change the function of this organ. Okay, till this one, you understand. Now, organ cannot work only by itself. It must communicate with others. So it will be organ systems. Organ systems. And from organ system consists full our body or organisms. So we will begin from atoms and end with organisms. Okay. Now, as I say, all your organs cannot live alone. They have to communicate to each other. Am I right? Of course I am. So, but how? Do they have their mouth, eyes, or hands maybe to speak with you? No. And to speak to another organ? Of course no. How they communicate to each other? Here must be some specificity. If something wrong happens, maybe with heart, what do you feel? When your heart cannot work normally, what do you feel? Increase of heart beating, some pain, pressure. Yeah, am I right? We'll speak about this slightly later, some minutes later. Yes, it is very easy, same idea, but please follow my description. Do not go away, please, because in the question I will give something that is only in my description, not on presentation, and it's difficult to find in the book then. But it is easy, but how to say, not to look for all the books, better to listen me. So, as we say, they must communicate to each other. Okay. Let's see. What kind of communication do you know between the organs? Do you know some communication between the organs? What can communicate my hand and my brain? Bloodstream and nerve. Am I right? Of course. So, blood is everywhere, and as you remember from school, it's some liquid that goes inside our body, yes, makes some circle, so it's going from one side to another. Can you take some nutrition, maybe from the right hand, after circle, spread it to the left? Of course it can. It's spread it in the body, so it can. So, this kind of distribution of nutrition and exchanging of information named Humoral. Humoral connection. Humoral organization. It's a very old kind of, so all creatures has this one. Worms, one-cell creatures, well, without neural structure and so on, have humoral organization of exchanging some information between the organs and organelles. Understand? What is good? It's spread it everywhere. It can take some particles with it, some nutrition with it, take some atoms from the tissue to another site where it will work. Of course, in digestive tract and of course in endocrine system. So if you have thyroid here, it's produced some hormone. So it goes to the blood, and by blood it will be spread to all tissues and to all organs. Am I right? Okay, understand? Get it. It's about the humoral. Good is that it can take some particles. What is bad? It is very slow. For body, it is very slow. Can you imagine that you touch something very hot and it is humoral organization? So the particles that is burned is going to your, I do not know, via to other organs, and then I have information, oh, it's very bad, my dear, let's do something. It needs time if it is humoral, because bloodstream, it's blood like liquid streaming, how fast it can be. You will burn all your hand in this period. We need something more fast. What will be more fast? Neural organization. Nerves speed is so high that nowadays our scientists cannot give you specific speed number. Can you imagine? No, it's not so high like light speed, but for sure not very far from it, I think. So it's very, very high. So we have two kinds of communication: humoral, narrow. Humoral, slow, but can take particles with it. Narrow, very fast. Very fast, but what is minus? Minus is that I cannot take some nutrition from one side to another by nerve. Only information about it somewhere something is. And another, I do not need always very fast reaction. Can you imagine that sometimes I need very slow reaction on the some changing? Okay, to understand what I'm speaking about, imagine the heart. It's contracted. Now imagine that some muscles of heart changed and information is going to our central nervous system. So it sent nerve information that must be contraction to take blood to the body. I have problem with the tissues here. If it will be very fast contraction, it will rape my tissues. And heart will be raped and blood will go inside the body. Is it good for us? No way. So here I need slow information, slow answering on some on information. Okay. And here we take new word. And the main idea, one of two main ideas for today's lecture, homeostasis. What is homeostasis? Let's see, I find here 2 minutes, as I remember 2 minutes, yes. Video, it's great, my dear, why not? Let's see.
So what is homeostasis? Homeostasis is a term first defined by Claude Bernard in 1865. It means maintaining a constant internal environment. Wow, great. That really explains it, doesn't it? Let me try and make it a bit clearer then. Imagine the cockpit of a plane. It is packed full of dials and it is the pilot's job to make sure they all stay in the right place. If any of them change, he will correct the plane to keep them in the right place and the plane in the air. This is a bit like how our brain works. Sensors all around the body are measuring various things and sending the information back to the brain. The brain then does its best to keep all these things stable and constant to keep the body working properly. This is homeostasis, maintaining a constant internal environment. So what kind of things need to be kept constant in the body? Well, it's very important to keep our temperature the same at around 37 degrees Celsius. You can find out more about this in the video on temperature regulation. You also need to keep the levels of sugar in the blood constant along with levels of ions and water. Your blood pressure needs to be carefully monitored along with the amounts of waste in the blood, such as carbon dioxide and urea. Okay, so let's say one of these factors goes too high or low. What is the brain going to do to get it back to the normal levels? The answer to that is negative feedback. Negative feedback is the process where the brain uses either a hormone or a nervous system to send a signal to the part of the body that can rectify the problem. For example, after you eat a meal, your blood sugar level increases. You can see it on this graph. This is detected and the pancreas will release a hormone called insulin that causes the sugar to be stored in the liver. Therefore, as you can see on the graph, the blood sugar level returns to normal. Negative feedback is the loop from which the body detects a stimulus, reacts by responding accordingly, and brings the body back to the normal levels. So why is homeostasis so important? Our metabolism, which is all the chemical reactions in our bodies that keep us alive, is controlled by enzymes. These enzymes only work in very specific conditions. If these conditions change, they could stop working and we could die. Luckily, all this happens without you having to think about it. If you had to do it yourself, you would spend all day and night just trying to keep all these things constant and would have no time to do anything fun like watch videos of cats on the internet.
So, my dear, I think it's very beautiful done for you, but let's go by hour. What is homeostasis? It's the idea of balancing in our body. Balancing of what? And why it's equilibrium balancing and can be said how it is. It's not only one point, it's some range of it between portion. So I cannot say that balancing is only when your temperature is perfectly 36 and 7. No, it's from 36 till 37 normal range of temperature. If it is above or below this range, then some homeostasis exists. Okay, what we need for homeostasis? We need stimulus, sensor, control, effector. What is stimulus? Something changed. Maybe it's around us. Nowadays in Georgia is very windy weather, so this wind decreases the temperature outside. And if you are taking some light clothes, you will freeze. Yeah. So if you are freeze, your temperature decreases. So stimulus is wind outside. What is sensor? Your skin understands the temperature decreased. It's sensor. What happens then? This sensation is sent to the control specific organs in our body's central nervous system, where it is discussed what to do. What to do? Skin says that temperature decreased. What we have to do? And they give information to effectors, and effectors give you shivering or some other kind of changing. How do you think? Why we begin to shiver when it is cold? Can you explain? Who can explain? No one can explain? Through the shivering, small muscles are working. When muscles are working, what's happened? Energy exists inside. Energy bursts out, and energy is always what? Temperature. Don't forget, through any kind of chemical reaction, temperature increased. So, by the shivering and blood is coming more, your skin became more warm or warmer. Okay? Understand? So, this is how it works. So, body temperature exceeds 37. Sensors like nerve cells with the ending in the skin and brain, temperature regulatory center in brain, and sweat glands throughout body. So I spoke about the decreasing of temperature, and here is given some example of increasing of temperature. So when temperature increased, your skin gain information, or sensor organ gave information that I do not like this temperature, it's more than enough to me. Where it is sent? It is sent to the control center, central nervous system, where it is discussed between the nerve cells. And then information is given to the effector organs, here sweat glands, which perfectly begin to work, produce a lot of liquid, which cover your skin, and skin decrease temperature now. That's how it works. Okay, what else can we say? Look here, pH in our body as well is connected with homeostasis. Everything is connected, excuse me, with homeostasis, but pH, you know, what is normal pH? Slightly more than 7, yes, as I remember. So we have acid and base. If acid increased, will go to the acid side more. If base, pH will be changed to the base kind of. What is the name of this changing? Who remember? Acidosis, alkalosis. So what is acidosis? When acid is more than normal, it will be acidosis. Okay? If we have base more than normal, it will be alkalosis. Okay. So not one, not another, not acidosis, not alkalosis is good to our body. We have to change it and take it to the normal range. And here is normal range. 7.35, 7.45 for pH. Yeah? Okay. What to do? Homeostasis. So it was sent from the cells to the central nervous system. Central nervous system understands that something happens and give information to the effectors. And here can be effectors like nephrons as well, which will take with a liquid some specific particles and decrease alkalosis in our body, and as well as acidosis take from our body out like waste. Yes, some acid portion or base portion. Okay, why not? Through the diet, my dear, glucose level as well is changed, and it has specific range. But if it is very high or very low, as well, homeostasis will work. Yes, and take it in the normal range. So see, here is picture about the glucose in blood and excessive blood glucose. When it is low, excessive blood glucose exists here. When it is high, we decrease it. Okay? So it's regulated by the control center and effectors. How to name, and we will go back to this portion slightly later. How to name? So something changed. Information is sent to the central nervous system. Some discussion exists and sent to the effectors, which perfectly change the situation. Okay. If changing of situation on the opposite will help your body to maintain homeostasis. It's named negative feedback. So, sending feedback. Feedback from the central nervous system to the organ. Am I right? Okay. Which kind can be positive? Oh, it's good what you are doing. Continue, I will help you. Or negative. Stop doing, change it. Understand? So negative feedback, it's against the changing which exists in the body. Okay, what is symptom, my dear? We say that organs speak to each other, between each other. It's humoral neural organization and communication between the organs. Great. But as well, organs will speak with you. How they can? When something happens inside, you always see it. Like shivering, sweating, some freezing, some pain, some heart beating, yes, dizziness, weakness, and so on. All these kind of changing is named like symptoms. And you, like physician, have to read it. You have to read these symptoms. So when patient come to you, you will read what happened with the patient by the symptoms. You see that sweat is coming. You see he is shivering. He takes his hand and says that some dizziness exists or weakness in the body. You collect this information and understand what's happened and where. You can do it only if you know physiology. Without physiology, knowledge about anatomy will give you nothing about the treatment of your patient or understanding of causes in the patient. Systems that maintain the internal environment within the body all are directly associated with bloodstream. Let's see. Cardiovascular, for sure, with bloodstream. Distribution of oxygen, nutrients, water, hormones, WBC, RBC, antibodies, and heat to and from the tissues. Do not forget when you describe the blood circulation in the cardiovascular system, heat production. What is heat and how it is produced? At first, in the middle of our body, temperature is higher than on the distal parts. So, when blood is spreading from inner organ out, it takes this heat with it. So, distal part of the body takes the temperature that we have inside, and vice versa. It's then cooling at the skin and goes back to the middle of our body by the vessels and decrease the temperature in inner organ. How heat produced? By the chemical reactions in the tissues. Okay, get it. And by the increasing of speed of distribution of the blood, because the higher speed is try to run. The faster you run, the warmer you become. The same happens in every kind of tissues. Respiratory system. Here is exchanging of oxygen, yes, O2 on CO2. But how it happens? When it's exchanged, it will be distributed by the blood stream from the lungs to the body organs and tissue, from body organ and tissue to the lungs. Okay? So bloodstream is connected with the respiratory. Gastrointestinal system. Gastrointestinal or digestive tract. So how it is connected with the bloodstream? What is digestion? Digestion is taken nutrients. So some food that goes to the digestive tract then change mechanically and chemically. Okay, great. But the nutrients which produced here must be taken to the tissue. How it happens? Absorbed by specific cells, but taken to the bloodstream. And by bloodstream, it will be sent to another tissue, to the another organ, to specific organ maybe, like calcium to the heart and bones, like which one, let's take specific vitamins, maybe A vitamins to the skin. You remember that it's connected, A vitamin with the skin. Change the color of it as well to the yellow, if it is only keratin. Let's see which chemicals, which particles, which nutrients we have distributed by our bloodstream. We have only 4 of them: carbohydrates, lipids, proteins, and nucleic acids. Understand? It will be in the life science as well given to you, but for sure we have to speak about it because it's part of the physiology. See how it's connected physiology with the other subject, with the life science as well. Carbohydrates, which part is where we can find it? For sure it's in the sugar and starches. Why we need it? So if your patient come to you very weak without energy, he can take it and energy will increase. How? By chemical reactions of oxygenation and destruction of the carbohydrates in our body, but it's life science portion. We will give symptoms and understand which kind of macromolecules you need. So, when you are studying and studying very hard, when you are studying very hard, what do you want? Girls, you will understand me. When you're studying very hard, you need some chocolate. Am I right? Some sweet maybe. Maybe some Coca-Cola as well, why not? Or maybe tea with sugar, but something very sweet. Am I right? For guys and to person who is addicted to the cigarette, it will be cigarette, but we will speak about it later. Okay, when we will speak about the acetylcholine, but now I'm speaking about the carbohydrates. So why you need this sugar? Why you need some sweets? Because sugar, look here, is energy structure. Understand? So you need not sugar, you need energy. What it means that you are very, very tired. If you do not want to gain the weight, take stretches and some rest. If you do not think about your weight, take sugar. It will very fast fuel you with energy. Get it? Okay. Sugar is fast, stretches slow. Both of them give you energy. Stretches need time, that's why you can regulate and do not gain the weight by stretches. Sugar you will take so fast and so big amount of that you cannot control size amount of sugar. That's why it gave you extra weight. Okay, I am dietolic as well, so I know what about I'm speaking now. Lipids. What is lipids? It's fats. Fats, oils. So when you are sitting on diet, my dear girls, it's for you more than to guys, but guys as well. When you are sitting on diet, oh no, it's free in the oil. I will not say, oh no, this meat has some fat. You have to eat it. You have to eat it. Not big amount, but for sure must be in your diet to normal organization of the diet process. Why? Look here what happens. Oh my God. It's membrane hormones. Membranes and hormones. Can you imagine what I am speaking about right now? Hormones. If you will not take the fat and oils, you will change the exchanging of hormones. What will be, my dear? My God, I cannot find where we are. Ah, here we are. What will be? If hormones cannot be produced normally, it means that you will have problem with sickles inside you, maybe some extra hair will increase on your body. Do you need it? Of course not. I think not. So that's why I say that you need some fat in diet as well. Okay, where is it, my dear? Okay, so lipids you understand, carbohydrates we understand, proteins. proteins, yeah, it's myosin. Myosin gave you enzyme structures. Why you need it? To rebuild muscles, rebuild soft tissues. Okay, here's another idea. Myosin is in the meat. It's part of the meat because structure myosin is in the muscle. What to do if you are vegan or a vegetarian? How to take it? That is the point of discussing the nutritiologists. But does not matter if you are vegan or vegetarian, you can take some medicines because mushrooms, beans for sure have a lot, simply the same amount that the muscles in the meat have. Okay, next one. So collagen is given here, like a portion of it. Nucleic acids. Nucleic acids. It's DNA, RNA. And portion of DNA and RNA is as well in the myosin, in the muscles, because it has this DNA and RNA inside, but not only, my dear. Of course, trees have them. And cereals have them as well. And it is needed with us for genetic information. I think it's easy to understand. Okay, so these four macromolecules which you take with the nutrition through the digestion is absorbed from the blood, from the digestive tract to the bloodstream, and then sent to the specific organs where they need it. Okay. Now, urinary system here. What about urinary? How it's connected to the blood? Blood is liquid, so all this extra liquid from other tissues, organs is absorbed with the blood to the bloodstream, then taken to the kidney, where by the specific metabolic processes and some different pressure will be taken like wastes. Understand here? But with this liquid as well will be taken out salt and other metabolics. Okay? So when salt is taken out with the kidney, your blood pressure will decrease. If your kidney cannot take it out, it means that salt is in your body. And what is the main function of salt? Take liquid inside your body. It means the more salt you have, the higher blood pressure will be in your body. Understand? Okay. Let's see next. Immune system. It's a lymphatic system, my dear, and we will speak about it on the third semester for sure, but common understanding you have to have right now. Consists of phagocytic and immunologically active WBC. Inactivate foreign agent. When it inactivate, when it fight with it, when phagocytosis exists, it's a lot of waste here. What to do with this waste? Waste must be taken out from the tissues. How it can be done? It's absorbed with the lymphatic vessels connected with the bloodstream and fecalist or urine. Okay? Understand. Next one, skin. What about skin? How skin is connected to the blood vessel? Sweat glands, and it needs some liquid as well. Cutaneous blood vessels, which maintain heat balance. Connected. What about body fluids? The next portion we have to discuss is body fluids. From school desk, you know that human beings are mostly water. Mostly. Of course, in the age it will be changed, the percentage of it. So from about 70% of body mass in infants till 45% in old age. Normally, it's about 50–60% in adult men. Liquid part from all body structure cells. Okay, but which kind of liquid do we have? And where is the most, most liquid organ? Okay, let's say that like this. Brain and kidney, they have the highest proportion of water. Kidney, you understand, it takes out the liquid, so it's full of the liquid inside. But what about the brain? Okay, but take it by heart. Brain and kidneys have the highest proportion of water, which composes 50–58% for their masses. Okay? In contrast, teeth have the lowest proportion of water. Only 8–10. Of course, can teeth have the same like the brain? Brain is so soft, and teeth are so strong. Okay. Here's picture where is distribution of the liquid. Brain 80–85, teeth 8–10, lungs have 75–80% of liquid, heart as well 75–80, liver 70–75, kidney as a brain 80–85, bones, my dear, not very far from the teeth because both of them are bony structures, 20–25%. And muscle has 70–75 like a skin in our body. Okay. Compartment of fluids. Body fluids can be discussed in terms of their specific fluid compartment. Location that is largely separate from another compartment by some form of physical barrier. The intracellular fluid, further we will sometimes give you abbreviation like ICF. Compartment is a system that includes all fluid enclosed in cells by their plasma membranes. Extracellular fluid surrounds all cells in the body. Extracellular fluid has two primary constitutes: the fluid component of the blood, clot plasma, and the interstitial fluid that surrounds all cells not in the blood. Let's see, I will have here some pictures. Look. So what kind of fluid we have? We have cells, and in the cells we have some fluid which is barriered with the cell barrier, yeah? Encapsulated. So this is some capsulas inside which we have fluid, which we name intracellular fluid. Easy. Around this one, they are floating, as you see, these cells are floating in some specific fluid, which is named extracellular or interstitial fluid. Interstitial, between tissue. Some association with this word to understand interstitial, between tissue, between cells, okay? Okay. And we have another part of this extracellular is blood plasma, but plasma is the same kind of fluid, but perfectly in the specific vessels. Get it? Okay. But we spoke about the membrane that encapsulates the liquid in intracellular fluid, yeah? Each cell of your body encased in a tiny bubble of membrane. What exactly is its job? The plasma membrane not only defines the borders of the cell, but also allows the cell to interact with its environment in a controlled way. Why controlled way? What it means, my dear? I always speak with not only students but every kind of people, and always gave you some advice not to study by heart. Understand what is given. And one of the idea how to understand, make some association. So here is association between the cell and family. For me, it's the same. Cell is your home, where inside are family membranes, and the cell has your home, your house has some walls, windows, and doors. Family has its own rules, how to communicate with environment. Are you allowed to go out in night? Not always, not everyone. And nowadays everyone is encapsulated in quarantine. Yeah? Okay. But can you go to your family enemies? Not always. Can you open the door to some robbers, thieves, or murderers? No. Can you open your doors to family members or friends of your house? Of course. Yeah? Understand? It's some rules. The same happens in, where is it? Excuse me, my dear. I always forget that I change. Oh my God. Excuse me one moment. So the same is here. Here is given the plasma membrane not only defines the border of the cells, walls of your house, but also allows the cells to interact with its environment in a controlled way. Controlled way, it means it's some specific rules which you have to follow, not you, but cell must follow. Cells must be able to exclude, take in, and excrete various substances, all in specific amount. In addition, they must be able to communicate with other cells, identifying themselves as sharing information. Easy, yeah? To perform this role, the plasma membrane needs lipids, which make a semi-permeable barrier. What it means semi-permeable? Half permeable. Half, it means that yes, something can go through, but something cannot. Imagine, guys, where are you? Right. So imagine that is very narrow doors in your house. Can everyone go through it? If person is very fat, he cannot, okay? If you have a lot of cells in your hand, parcels or something, you cannot enter. So the same happens here. Semi-permeable means that some can go through, but some, okay. So, semi-permeable barrier between the cell and its environment. It also needs proteins which are involved in cross-membrane transport and cell communication, and carbohydrates, sugar, and sugar chains which decorate both the proteins and the lipids and help cell recognize each other. I will show you it on the picture. See? So once again, see these red balls with some lines. Yeah? What it is? It's phospholipid layers. How many do we have? Two. One layer where you have head and their tails, and another layer of head and tails. What we say? We say that we have protein channels, proteins here. Do you remember we say? Why we need proteins? It makes some channels. It's like corridors between the layers. As well, we say that we have some glycolipids, like antenna is given here, yes, and carbohydrates and other kind of chains. which recognize some structure who is coming. Oh, you are my friend, come here please, and so on, and to give permission to go inside the cell. Understand? Yeah. Once again, where is another structure? Here. Here is better picture. See, one layer, another. So what we have? B layer. Okay, what B layer of what? Phospholipids. Phospholipid connect from which part? Head and tails, fatty tails. Yes. So what we have inside? Cholesterols, peripheral extrinsic proteins, integral or taken inside proteins, intrinsic proteins it's named, and sugar chain or carbohydrates chain. Okay, get it? Like antenna. Okay, let's read what else is given. Okay, here. According to the fluid mosaic model, it's named mosaic model, this picture, my dear. The plasma membrane is a mosaic of components, primarily phospholipids, cholesterol, proteins, that move freely and fluidly in the plane of membranes. In other words, a diagram of the membrane is just a snapshot of dynamic process in which phospholipids and proteins are continually sliding past one another. The principal components of the plasma membrane are lipids, phospholipids and cholesterol, proteins and carbohydrates, groups that are attached to some of the lipid and proteins. Phospholipid is a lipid made of glycerol, yes, in English, two fatty acid tails, we spoke about it, and phosphate-linked head group. Biological membranes usually involve two layers of phospholipids with their tails pointing inward, and arrangement called phospholipid bilayer. See? Okay. Cholesterol, another lipid component of four fused carbon rings, is found alongside phospholipids in the core of the membrane. Membrane proteins may extend partway into the plasma membrane, cross the membrane entirely, or be loosely attached to its inside or outside face. Carbohydrate groups are present only on the outer surface of the plasma membrane and are attached to proteins forming glycoproteins or lipids forming glycolipids. The components of plasma membrane, phospholipids, main fabric, here is only the same description, I do not need. So, once again, fluid. You remember what we say? We have extra, intra, yes? Let's begin. Extracellular, intracellular. It's not perfectly half by half. Intracellular is slightly more than extracellular. Intracellular is bordered with the plasma membrane. What is plasma membrane? Bilayer of phospholipids and some proteins and cholesterols, including extra or intra-bilayer structure. What about the extracellular fluid? It consists of interstitial fluid. What is interstitial fluid? Where the cells are, and around the cells we have this fluid. We have plasma, which is in the blood vessels and which is not mentioned before, other fluid. What kind of other fluid? It's tears, saliva, and digestive tract, some liquids, of course, and sweet. Understand? This kind of is not mentioned in previous our slides, but for sure it is some amount of this fluid in our body, so we have to speak about it as well. The ICF, intracellular fluid, lies within cells and is the principal component of the cytosol. What is cytosol? Cytoplasm. The ICF makes up about 60% of the total water in the human body, and in an average-sized adult male, the ICF accounts for about 25 liters. 7 gallons of fluid. Can you imagine? Extracellular fluid. ACF account for the other one-third of the body's water content. Approximately 20% of the ACF is found in plasma. Plasma travels through the body in blood vessels and transports a range of materials, including blood cells, proteins, electrolytes, nutrients, gases, and wastes. Gases, nutrient, and waste materials travel between capillaries and cells through the IF. Interstitial fluid. Cells are separated from the interstitial fluid by a selectively permeable cell membrane that helps regulate the passage of materials between the IF and the interior of the cell. The body has other water-based extracellular fluid. This includes the cerebrospinal fluid that bases the brain and spinal cord, lymph, the synovial fluid in joint, and pleural fluid in the pleural cavities, the pericardial fluid in the cardiac sac, the peritoneal fluid in the peritoneal cavity, and the aqueous humor of the eye. Because these fluids are outside of cells, these fluids are also considered components of the ECF compartment. One more picture. Beautiful. And about the transport, we will speak later, my dear, on another our meeting for sure, because it will be big amount for you to understand, not to understand it, easy to understand, to reread and take on the specific shelf in your brain. So that's all what I want to speak with you today. If you have any question, please type me. I'm waiting. Someone is given. One moment, please. The fluid in the brain, is it just the... Cannot understand CSF. How do you think? We say that we have cells inside. We have a fluid and we have outside. Yeah? So, saliva is not here for sure. Very, very small amount is produced for lubrication by specific cells. We will speak about it later, when we will speak about the nerves, and we will speak it maybe next our meeting. Yeah, transport and nerve cells. Yes, here is from another professor for sure, which I show you is short kind of, which I used only for visualizations the lecture, and I think it's easy. But for deeper understanding, better to check these ones, which is uploaded on your portals. It was done by a very good professor, so why not? And as well, you have to read the books, my dear. It's not enough only my speech to do it. What is good in my lectures that I organized and gave you a very simple way of understanding. Like I never use very dramatically high medical language. I think it's easier to, when you understand something, you can study. If you only hear the voice and some very not interesting, boring words, you cannot study this subject, I think. That's why my students always in the physiology take high marks, because I never used it. But I gave you understanding. It's not enough. You have to read and take in the specific shelves in your body. Okay? That's how it works. What else, my dear? In the PPTs which are on your drive, simply the same is given. Maybe slightly more medical language, which is useful to you to read and to study. If no question exists, my dear, I only thank you for your attention, and we will meet next week at the same time, okay? Please follow my lectures, because, as I say, this first is very easy. When we will go on the action potential, and it will be slightly difficult to understand only in the books. And I will try my best to chew it to you and give you the easiest way to understand. Okay? Thank you once again. Bye.